Hi, my name is Muhammad Lutfi Farhan bin Muhammad AZAR.
Alright, hello, my name is Ahmad Shukri bin Muhammad Shukur.
Hi, I'm HARRAZ HAKIM bin AREF HAKIM.
Hi, my name is Nur Alia Shakira binti KAMARUZZAMAN.
Hi, my name is FATEN QISTINA binti ROSLI.
So hi, so for today's video, I'm gonna start the video with introduction of logical implications. So the statement if P then Q is also written as P implies Q. The symbol arrow means implies. This arrow is to design the statement which is the implication of Q by P. So the conditional of P implies Q is also can read as if P then Q, Q if P, P only if Q, Q wherever P and Q from P. So we actually commonly use the conditional statement is point 1 and point 2. So that is P if P then Q and Q if P. So for the negation of conditional statement, so you can consider a statement if you decide to go to the party, then I will go with you. So how to rephrase it? Then to rephrase a negation of a statement, first is we have to do is to create a truth table. So I have created a truth table on this statement. So this is the complete truth table shows that the negation not P implies Q is logically equivalent to the conjunction of P or not Q. So now we can rephrase the statement as from if you decide to go to the party, then I will go with you, to you decide to go to the party, but I didn't go with you. So now we have rephrased the statement. So for the related conditionals, we have three types of related conditional. That is the converse, the inverse, and the contrapositive. Now we choose a simple statement for this part. So I choose this statement. If you stay, then I leave. So for the P statement is you stay for antecedent, and for Q I leave for consequent. So for the conditional statement for this statement is P implies Q. So you can see the converse. The converse is obtained by interchanging antecedent and consequent. So it's like a swap. P implies Q to Q implies P. In English form, if I leave, then you stay. So that's for the converse. For the inverse, it's obtained by negating the antecedent and the consequent. So from P implies Q to not P implies not Q. So in the English form, if you do not stay, then I do not leave. That is for the inverse step. Then next, we can see the contrapositive. This is the one of the most important related conditionals because the contrapositive is based on uh, the two of before the contrapositive. There is converse and inverse. So it's obtained by both negating the antecedent and the consequent and by interchanging them. So that means you use converse and inverse step in one single method, that is contrapositive. So from P implies Q to not Q implies not P. So you can see the English form, if I do not leave, then you stay. So that's all for the introduction. Thank you.
Right, so for the first example, which is example 1, there is statement there are state which is to use the truth table to determine whether P or Q implies R are logically implies to P implies R. Alright. Alright, so to determine whether the P or Q implies R logically implies to P implies R, so we use the truth table to solve this example, which is we make a truth table and just put all the variable from the statement, which is we have a P, Q, and R, and then we move to the next statement, which is P or Q, only P or Q, and then the next column we move to P or Q implies to R, and then we move to P implies R, and the last column, which is to prove there is statement is logically implies to another statement, which is we have to look at the last column to see whether there is a tautology or not. Alright. Okay, so for the next step, we put the truth value, which is for P, for 0, and then for 1, and then we put for the Q to 0, to 1, to 0, and to 1, and for R 0, 1, 0, 1, 0, 1, and 0, 1. Alright, so we look to the next column, which is P or Q. So for P or Q, if there is a true and true or true, no, if there is a false and false, then there will be false. So if there is no false or false, other than that statement will be true. So we look at this P or Q, we have false and false, then we get false, and also this we got false, and other than that we don't have other false and false, so they will be all true. So for the next column, which is we have a P or Q implies to R, which is for this statement, if there for the implies, if there is the true implies to false, then we got false. So from the truth table, we see that the column number 3, the row number 3, we get true and false, then we will be a false. Same goes to this, we got true and false, we got false, true and false, we got false, and other than that we got a true. So next is P implies R, also have the same meaning like before. So if there is a true and false, if there is a true and false, we got a false, and then same like this, true and false, we got false, and other than that we all got true. So for the last column, which is to determine whether the statement are logically implies, we see that all the truth value at the last column was true, and there is a tautology. Alright, so to wrap it up, all of this example 1, so we know that for the last column, which is we got all the true value are true, and there is a tautology. So since the statement P or Q implies R logically implies to P implies R, there is because the last column was a tautology. So the tautology means that the last column of the true value, we got all true, and we know that the statement was logically implies to each other. So I think that's all from me for example 1. Thank you.
Now let's go to law of detachment or modus ponens. Any argument of the form is a valid argument. It is known as law of detachment, or also known as modus ponens, which is its Latin name. Law of detachment also can be defined as if P implies Q is true and P is true, then Q is true. Next is the fallacy of the converse. Any argument of the form is an invalid argument. It is known as the fallacy of the converse, which means the conclusion can be false even when the premises are true. Example 2. If today is Sunday, then we have class today. We have class today, therefore today is Sunday. Determine the validity of this argument. Firstly, we need to write the argument into primary statement. If today is Sunday, then we have class today will be premise 1. We have class today will be premise 2, and therefore today is Sunday will be the conclusion. By using P and Q, we need to write the argument into primary statement. So, P will represent today is Sunday, then Q represent we have class today. Next, we need to write the argument into symbolic form. This symbolic form shows that it is the fallacy of the converse, which means this is an invalid argument. Also, we can derive a truth table to determine the validity. First column represents P, second column represents Q, and the last three columns represents premise 1, premise 2, and also the implication. The last column shows that it is not a tautology, which means it is a contingency. Hence, this argument is invalid.
So if we see any argument in the form of P implies Q and not P with the conclusion not Q, this is called the fallacy of the inverse. So any argument in this form is an invalid argument. So the next one is law of contraposition, or it is known as modus tollens. So this argument is in the form of P implies Q and not Q, and then we get the conclusion not P. So this is different from fallacy of the inverse because this argument is a valid argument. For the last one, disjunctive syllogism is in the form of P or Q and not Q, with the conclusion P is also a valid argument. Example 3, we have to determine the validity of the argument. So we are given the argument, if I like singing, then I like music. So the second sentence is, I hate music, therefore I hate singing. So step 1, we have to write the argument in a symbolic form. So we can classify the sentence R for I like singing and S for I like music. And then we will get the symbolic form for this argument, which is R implies S and not S, therefore not R. So as I explained earlier, this type of argument is known as law of contraposition or modus tollens. So any argument in this form is a valid argument. But we have another way to solve this type of question, which is using the truth table. So based on this question, we can see the last column in the truth table is a tautology. Hence, this argument is valid.
Now we move on to the conclusion of logical implication. What we have learned about this topic. Firstly, we can make replaces statement by using this logical implication. How to identify which is antecedent and consequent. The information that we have to know is the rule of implication is when antecedent is true and consequent is false, therefore the statement is false. We can also use truth table to find the value. Also in this topic, we will also learn how to arrange negation statement. If we find this statement, we need to separate the statement into symbolic. After that, we just expand and solve it. Lastly, determine which statements are equivalent to relate conditional. In addition, there are three important forms of conditional statement, which is converse, inverse, and contrapositive. Converse just swap both sides.
Inverse obtained by negating and the antecedent and consequent. Lastly, contrapositive is by changing side and add the negation for two sides. So that's all for our presentation, and bye bye.